In the summer of 2025, a telescope in Chile spotted something moving through our solar system that shouldn't be there. An object from another star system entirely. One of Harvard's leading physicists studied its behavior and counted 15 anomalies that science still can't fully explain. He said it might be artificial, possibly an alien spacecraft. NASA's official position is far simpler. It's just a comet. But even now, over a year after its discovery, some of the data still doesn't add up completely. This is the story of 3I/Atlas, and the argument it started that still isn't fully settled.
So what exactly makes something interstellar? Every comet and asteroid you've ever heard of belongs to our solar system, held in a closed orbit around the sun by its gravity. An interstellar object is different. It doesn't come from here. It arrives from deep space, moving on a hyperbolic path, meaning it's moving too fast for the sun to ever capture it. It swings past once, and then it's gone forever, back into interstellar space, never to return. These objects are essentially samples from other star systems, drifting through ours completely by chance, giving us a rare, temporary glimpse of material that formed somewhere else entirely.
On July 1st, 2025, the Atlas Survey Telescope, located at the Rio Hurtado Observatory in Chile, picked up a faint point of light moving along an unusual path. Within days, astronomers confirmed something remarkable. The object was traveling at roughly 245,000 kilometers per hour, and it had arrived from outside our solar system entirely. It was given the designation 3I/Atlas, named after the telescope that found it, and marked as only the third confirmed interstellar visitor in the history of human observation. A small half-meter telescope in a remote Chilean valley had just spotted a guest from another star.
Before 3I/Atlas, humanity had recorded only 2 interstellar visitors. The first was Oumuamua, discovered in 2017, an elongated reddish body with no visible tail, which immediately sparked debate about whether it could be artificial. Telescopes could barely resolve it. Most images showed nothing more than a faint point of light streaking past the stars. Then came Comet Borisov in 2019, which behaved almost exactly like a comet from our own solar system, releasing gas and dust as it approached the sun, with nothing particularly unusual about it. 3I/Atlas became the third confirmed interstellar object and immediately stood out. It was larger and considerably brighter than both of its predecessors, which meant scientists suddenly had far more data to work with than either of the previous 2 visitors had ever provided.
Within the first few weeks of observation, inconsistencies began to surface. The object turned out to be unusually large for something that had traveled between the stars, far bigger than either Oumuamua or Borisov had been. It also lacked the classic cometary tail that astronomers expected to see, given how close it was getting to the sun. Spectral analysis added another puzzle. It showed the presence of nickel without the cyanide gas that normally accompanies it in natural comets, a rare and unusual combination. On their own, each of these details had a plausible explanation, but together, they started adding up to a genuine question mark.
The person who took on the anomalies was Avi Loeb, a professor at Harvard, co-founder of the Galileo Project, which searches for signs of extraterrestrial technology. He was the first, back in 2017, to suggest that Oumuamua might be artificial. His reputation is mixed. Some colleagues respect his willingness to question standard explanations. Others see him as prone to sensationalism. But it was his analysis of 3I/Atlas that pushed the story onto the world stage.
Even Loeb himself has been careful with his language, writing that the object is most likely a natural object, while still keeping his anomaly count open for debate.
Loeb compiled a list of 15 anomalies: an abnormal size, the missing tail, an unusual chemical makeup in its coma, a strange brightness curve, and an oddly precise trajectory past several planets, among other details. He measures each interstellar object on his own scale, from 0, meaning an ordinary comet, to 10, meaning hostile alien technology. For 3I/Atlas, he gave a rank of 4, most likely a natural object, in his own words, but one that still deserves close scrutiny. Not proof of anything artificial, just a list of open questions that hadn't been fully closed yet, sitting right in the middle of his scale.
Trajectory calculations revealed something unusual. The path of 3I ATLS passed strikingly close to the orbits of several planets in our solar system, including a close approach to Jupiter in early 2026. For a random object arriving from interstellar space, that kind of alignment is statistically unlikely, Loeb pointed out. It's one thing to cross a solar system at a random angle. It's another to thread a path this close to multiple planetary orbits by pure chance. This coincidence of trajectories became one of the central points on his list of anomalies, not proof of design, but a detail that refused to be dismissed outright.
Loeb also raised a more unsettling scenario, echoing an idea known as the dark forest hypothesis, the notion that advanced civilizations might choose to stay hidden because revealing their technology could attract hostile attention. He described the encounter as a blind date of interstellar proportions. There's no way to know in advance whether a visitor like this is friendly or dangerous. It's a thought experiment, not a claim of certainty. Loeb himself stressed the odds still favor a natural explanation. But the statement was enough to trigger a wave of coverage around the world, ranging from serious science outlets to outright panic headlines.
On October 29th, 2025, 3I/Atlas reached perihelion, the closest point of its path to the Sun. At that moment, the object sat on the far side of the Sun relative to Earth, completely out of reach for direct observation. A week later, the European probe JUICE, positioned near Jupiter, captured it from a distance of 66 million kilometers. The image revealed a bright glowing coma and a long tail of dust and gas trailing behind the nucleus. It wasn't a dramatic close-up, just a faint smear of light against the dark, but it was real, direct confirmation. Whatever this object was, it was behaving unmistakably like a comet. In late December 2025, the Hubble Space Telescope captured new images. The raw photo showed a glowing, teardrop-shaped coma stretched toward the Sun, already unusual for a comet at this distance. Independent researchers went further, applying image processing filters to the public Hubble data, and found something striking underneath. A symmetric anti-tail pointed at the Sun, alongside what looked like 3 evenly spaced jets of gas around the nucleus. That kind of geometric regularity is rare in comets, and it reignited the debate. Is this just the shape nature happened to produce, or a sign of something more ordered? The raw data is public. The interpretation, for now, is still contested.
Most astronomers, including specialists at NASA, insisted that every observed feature fit within known cometary physics. The unusual composition was explained by a rare but not unheard of icy makeup of the nucleus. The missing tail was chalked up to the object's low temperature at the time of discovery. David Jewitt,
an astronomer at UCLA who has studied comets for decades, put it simply: 3I looks to me like a comet. At a NASA press conference on November 19, 2025, officials stated plainly that the object behaved like a natural comet, just one with a slightly more distinctive set of individual traits than most.
As new data came in, even Loeb began softening his language. In his own writing, he stated that 3I/Atlas is most likely a natural object, while keeping the door open on the smaller details. In March 2026, he went further. Citing the growing body of observations, he lowered his own anomaly rating from 4 down to 3 on the Loeb scale. Not 0, he still flagged unresolved questions, but not the same confident 4 he'd assigned back in July 2025 either. This was a turning point in the story. The loudest voice behind the theory had quietly admitted there was no hard proof of anything artificial.
Here's the honest bottom line. Confirmed, the object's origin from outside our solar system, its unusual size, and its distinctive chemical makeup. Not confirmed, artificial origin, hostile intent, or any departure from the known laws of physics. A handful of details, the exact reason for the missing classic tail, and the symmetry of the jets, remain genuinely debated among specialists to this day, more than a year after discovery. Science didn't deliver a clean verdict here. What it delivered was a narrower, better defined mystery, which, in its own way, is still progress.
A similar story already played out once before. In 2017, the unusual shape of Oumuamua also sparked theories about artificial origin. Years of follow-up research later, most scientists settled on a natural explanation: outgassing of hydrogen as the ice warmed under sunlight. The story of 3I Atlas is following the same cycle: sensation, analysis, debate, a slow narrowing of the unknown. Science doesn't move in a straight line toward an answer. It moves through rounds of exactly this kind of argument: messy, public, and occasionally uncomfortable, but ultimately how the unknown gets smaller.
By 2028, 3I/Atlas will cross the orbits of Saturn, Uranus, and Neptune and leave our solar system for good. We will never see it again. It became the third interstellar guest in the history of human observation. But it won't be the last. With new observatories coming online, like the Vera Rubin Observatory, astronomers expect to find objects like this every single year from now on. The debate around 3I/Atlas didn't end with a clean answer, and maybe that's the point. Every interstellar visitor is a test of how carefully we're willing to look before we decide what we're seeing. The watch continues. Subscribe to be the first to know when they find the fourth.